Okay, before we start our today's session, let me open our usual spreadsheet and we'll quickly update our discussion points. Okay, so in our previous sessions, we discussed about the VAMI use cases. So can anyone tell me what is VAMI? What is a full form for VAMI?
VMware vCenter Appliance Management Interface.
Yeah, very good. It's a vCenter appliance management interface. And we observe the organize and inventory of virtual objects. Okay, virtual objects is nothing but a creation of data center and adding the host to data center and creation of virtual machine and deploying the multiple virtual machines from the template. These all we organized in our vCenter. This is nothing but a vCenter level virtual objects and basic storage concepts we discussed yesterday. And the main basic storage concepts are block storage, file and object storage. We observe the main use cases for three storages. And the storage protection also we observe like RAID concept. And today's session, we are going to start with the vSphere storage overview. So previous session was mainly onto the basic storage. So today we focus on the vSphere storage and we are going to observe the physical architecture, virtual architecture differences in storage perspective and storage technologies and comparison of all the vSphere storage technologies. And finally, we'll do the lab for NFS storage. Okay, and labs also we are familiar for creating the virtual machine at vCenter level and creation of template also we did and deploying virtual machines from template also we did and local data store. Yesterday we created the ESXi host local data store on our 3 ESXi hosts. So today we are going to observe the NFS data store management. Okay, so we'll start. Let me open the slide. Okay. So in our vSphere storage concepts, so there are mainly 4 types of data store. So today we cover the one data store, which is NFS data store configuration and management in our Homelab. Okay, within the storage, it's a session 2. And today's agenda is, as I mentioned, physical architecture and virtual architecture differences in storage perspective and vSphere storage, what type of data stores we have. And I will also quickly give you the vSphere storage overview. Once we understand the overview, it's easy to deep down onto the remaining concepts. We can easily deep dive the all concepts. Okay, and also I will give you the storage technologies and I will try to explain in a conceptual diagram. This is also very important to understand all the storage concepts and comparing the types of storage. And finally, we'll do the NFS storage architecture and components and we'll perform the Homelab. Okay, so we'll start with the first point. It's a physical architecture and we are going to compare with the virtual architecture. Let's verify the diagram first. Suppose in the physical architecture, if you see the physical architecture, we need a one server that is nothing but a x86 architecture. X means any 64 architecture. You can use any Intel motherboard or you can use a AMD and you can use any HPE server or other vendor servers. On top of the physical server, we are installing the operating system like Windows. If you install the operating system Windows, the file system is NTFS. And suppose if you install the operating system is Linux, file system is ext4. It's a extended file system version 4. Suppose if you install any Unix flavored operating system, the file system is UFS. It's a Unix file system. So this is a file systems available in a normal physical servers. When we install the operating system, there should be some purpose to install OS. So later we can configure the respective project related applications. If your project is related to any DB application, you can install DB. For web server, you can configure the web services on your application operating system level. Okay, so like that we can configure any web server or web app server or DB server. Normally, most of the applications are 3-tier architecture. 3-tier architecture means first tier is web, second tier is app, and third tier is database. So most of the real-time scenarios, all the physical server running with these 3 types of servers: web server, app server, and DB servers. Whatever the server you consider, the storage is formatted with either NTFS format or EXT format. But the one drawback in the physical architecture is whatever the local hard disk you're using, this hard disk we cannot share it to the another server. It will be like a dedicated for specific server only. But when comes to the virtual architecture, here we have a storage, but this storage is not like a NTFS or EXT. There are multiple file system formats in ESX environment and also vSphere, vCenter environment. When I say vSphere means it consists of both ESX and vCenter. In vSphere environment, we have the data store. That data store is also called it as shared storage. This the name itself says shared storage. That means this data store is shared between the host. So it's not limited to two hosts. It's among the multiple ESXi hosts. We can share the data store. That is a benefit when compared to physical architecture. But in the virtual architecture, whatever the data store I create, the supported data stores are VMFS data store, NFS data store, network file system, vSAN. vSAN means virtual SAN, and vSphere virtual volumes. In virtual volumes, in short form, we call it as vVols. vVols is nothing but a virtual volumes. These all the storage types is supported for shared storage. You can share the data store to multiple ESX. In this diagram, I'm trying to show you on a 2 ESX host. So here also x86 architecture for both hosts, and we install the ESXi operating system. That is nothing but a hypervisor operating system. On top, we'll create a virtual machines. Here also virtual machine. And virtual machine disk VMDKs are stored on a shared storage only. So with this storage, shared storage, we may get some additional benefits. So those benefits I mentioned in the notes. So storage options give us the flexibility to set up our storage based on our cost, performance, and manageability requirements. So it's always in the customer requirement, whatever the cost they have based on their requirement, we can choose their storage. You can choose either VMFS storage or NFS, vSAN or vVols, anything we can choose. And we have flexibility to choose any of the storage. And VMware VMFS means virtual machine file system, provides a distributed storage architecture where multiple ESX hosts can read and write to the shared storage concurrently. Concurrently is nothing but a simultaneously. Okay, simultaneously, all ESX hosts can access the same shared storage, and they can create the virtual machine, delete the virtual machine, and do any kind of modifications. So that is a benefit of one benefit of shared storage. There is some additional benefits. See, shared storage is useful for disaster recovery. Disaster recovery means suppose in this diagram we have a two ESX host. All of the sudden, one ESX host is completely down. Some hardware issue, host is completely powered off. During the power off, there is no impact to the virtual machine. If you have a shared storage, these VMs are automatically migrate on another host and rebooted from the second ESXi host. That means when the disaster happen on any of the one ESX host, or is it not limited to host, even if the disaster happen on one site, during that scenario also we can use a different site to restore your virtual machine on a secondary site. That is nothing but a disaster recovery. Normally in the VMware scenario, disaster recovery purpose, we'll use a separate tool, the tool name called VMware SRM. SRM means Site Recovery Manager. That is one of the disaster recovery. Even during that scenario also, it's recommended to use shared storage. And another feature is high availability. High availability also same, when the ESX host is fail, all the VMs are migrate and restarted on another host. That feature is nothing but a high availability. And moving the virtual machine between the host. Suppose if I want to move virtual machine from one host to another host also, it recommended condition is we require a shared storage. This moving virtual machine or migrate virtual machine is nothing but a vMotion. And normally which scenario we migrate the VMCs, we can migrate the virtual machines from one host to another host in a generally multiple scenarios. One scenario is when you plan to do any ESXi host maintenance, either it is hardware maintenance, or if you plan to do ESX host patching, or if you plan to reboot the ESXi host on annual basis. Normally some companies they maintain annually one time they restart all their ESX boxes. As part of annual restart of ESX also, before restarting one ESX, first to place the host into maintenance mode, migrate all the VMs to, it will automatically migrate to another host. How it is migrating automatically is the backend mechanism is vMotion. Okay, so this is the benefit of virtual architecture in our virtual architecture, the main key concept is shared storage. Okay, within the shared storage, there are multiple data stores. So this data store, we are going to discuss some more additional points. Okay, excuse me. So vSphere storage data stores. So a data store is a logical storage unit that can use disk space on one physical device or span several physical devices. It's not limited to one physical, even you can use multiple physical devices to configure as a logical storage unit. That logical storage unit is nothing but a data store. So data stores are used to hold virtual machine files, templates. Template means it is a master image of virtual machine, and also you can store in your data store, you can store ISO images as well. ISO image means Windows ISO, Linux ISO, Solaris ISO, and any of the third party virtual appliance ISO files. Okay, virtual appliances, some appliances are in ISO format, some appliances are in a .ovf or .ova format. All these files you can copy in a data store level. That is a use case for the data store. And a virtual machine is stored as a set of files in its own directory or a group of objects in a data store. Even when we open our data store, suppose if we connect our lab vCenter, go to the data store. See, yesterday we created the data store. So ESX1 one data store, ESX2 one data store, ESX3 one data store we created. But these three are the local data stores. For example, if you want to see the files here, select the data store, go to the files. See here you can see the files, but is there any virtual machine? Seems to be no virtual machine is created. This is a default data store related files. Suppose if you want to create the virtual machine, go to the host and cluster, right click the cluster, choose new virtual machines. When I select the new virtual machine, click on next, and here whatever the host you want to create, you can create, and the virtual machine name, any name you can mention. Let's say test VM01. This test VM01, we have to choose the specific host because there is no shared cluster, shared data store. So I'm selecting the ESX1. So ESX1 compatibility is succeeded, and you can choose the local data store next, and you can choose a default compatible with the latest version and also the advanced version. Click on next. Suppose I want to install a 2019 or 2022. Choose the guest operating system, and the default settings, we do not have the enough space, so let's choose the space as a 15 GB. Okay, now no error message. These all the default configuration settings, and the storage also always recommended is thin provision, and choose the thin provision. And the remaining settings are, let's use the default settings. Click on next. Now we can see the all the options. Even the NIC type also, if you want to change to VM 3, just click on back and go to the network. Under the VM network, you can just modify to network type, you can modify to VMX 3. Okay, so now click on next, click on finish. So in the recent task, create virtual machine is in progress and it is completed. We can see the test VM here. Whenever we create a virtual machine, in order to see the virtual machine files and all, we have to select the virtual machine. In the right side also, you can see the data store name. This VM is stored on the storage. You can just click on the storage. It will directly redirect you to the files. So here you can see our test VM folder. The same point I mentioned in our slide. So if you select the test, see you can see the default files. Virtual machine configuration file, virtual machine disk file, snapshot data file. Snapshot data file default size is 0. Even VMDK also we haven't installed the operating system, so the size is 0. And this is also virtual machine log file. The remaining files, when the VM is power on, it will create some additional files like NVRAM file and also some BIOS files it will create. Okay, so the same point I mentioned here. A virtual machine is stored as a set of files on its own directory. Directory means it's a folder and virtual machine folder, or as a group of objects in a data store. Okay, and also data stores are holds mainly virtual machine file, template, and ISO images. And vSphere means ESXi and vCenter server both supports the following types of data stores. Those data stores are VMFS, that means virtual machine file system, NFS, network file system, virtual SAN, and virtual volumes. So, so today we try to discuss on some basic points on all the four storages, and the following sessions will do the lab for each data store. Okay. So hope you understand the data store types. We have mainly these four data store types. Now let me show you in a logical view virtual diagram. I'm trying to show you these data stores. In this diagram, we understand that we have two ESX hosts. It's running with two virtual machines. These two virtual machines are stored on a data store level. Same data store it's stored. Okay. The same one I'm trying to explain in a two types of data stores. Let's move on to the next slide. Okay, if you see this slide with the two different type of data store, let's start from first. Suppose this diagram, if you see in the left side one, we have a two ESXi host physical servers. On top of the physical server we install the ESX. On top of ESX we created a multiple virtual machine, but in order to store the virtual machine we need a one data store. So that data store can be either NFS data store or VMFS data store. Normally NFS data store means yesterday we discussed that is a file storage type. Okay, that is one of the file storage type model. And if you want to configure vmfs we can configure in a block storage type. Okay, and when we want to create a virtual machine on NFS data store, we need a normal internet connection. For internet connection, the minimum recommended speed is 1 GB Ethernet, 1 Gbps Ethernet. E means Ethernet. Ethernet means it's a kind of LAN, and the 10 Gbps also recommended. Minimally one, and recommended is 10 GB. Even if you maintain more than 10 GB also, it will provide a better performance to your virtual machines. So if you see all the virtual machine through the network, it's connected and stored all the VMs on a data store. And this data store is configured on file server. Whenever we configure a file server with NFS protocol, it become as a NFS data store. NFS is a protocol name and also the data store name. Both are same. And all the VMs stored in the data store and the communication purpose, they use the protocol name is NFS, Network File System Protocol. And let's observe the second scenario. In the second scenario also we have two ESX hosts and running with multiple virtual machine, but only difference is here the data store name is VMFS. For VMFS data store configuration, it's require a block storage. Block storage means we can configure on a either local storage, you can configure on a fiber channel SAN, or you can configure on a iSCSI SAN. For any storage area network and local storage, we are able to configure as VMFS. For example, let's quickly connect to our data store. If we select the data store in our lab system, go to the data store, you can see all our local data stores are configured with VMFS 6 partition. Current latest version is VMFS 6 and our data store type is VMFS 6. That means local data store also formatted with a VMFS 6 only. And similarly, even if you configure a SAN data store, SAN also configured with VMFS format. So you can store the virtual machines either in VMFS format or you can store in a NFS format. And we also have a additional storage models, that is a vSAN. vSAN is nothing but a software defined storage. It's only using VMware vSAN software only we can configure. It's a software defined storage. In other terminology, we can also call it as SDS. SDS means software defined storage. When it comes to virtual volume also software defined storage, but this can be configured on any type of storage container. That storage container can be either NAS storage like NFS, or it can be a fiber channel SAN. Any of the storage, whether it is a fiber channel SAN or NAS storage, network attached storage, vVols as a acts as a software container. You can take the storage, you can create virtual volumes on any type of storage container, whether it is FCSAN container or a NAS container. Okay, once we under familiar with the first three data file systems or data stores, we can easily understand the virtual volumes. Okay, so hope you clear about this diagram. Clear? vSphere data stores. just I'm not deep dive into the topic. I'm just giving the brief information what type of data stores our vSphere storage is supports. Okay. Now I will little elaborate some more all the vSphere storage overview. I'm trying to explain in the next slide. Okay. So whatever we discussed just now, the same data store, I'm trying to explain a little more deep. Let's start from the top. Suppose in the top we have a virtual disk. All the virtual disk for dedicated for virtual. Every virtual machine have one virtual disk. If you create a two hard disks for each VM, there will be a multiple virtual disk. So we know how to create a ESX and create a virtual machine. So this top section refers as a it contains multiple virtual disk. So to store the virtual disk, we need a some data store type. The data store can be you can store on VMFS, you can store on NFS, or you can store on vSAN, virtual SAN, or you can store on a vSphere virtual volumes. Why we mentioned vSphere virtual volumes means we even there is a third party tools also supporting for virtual volumes, but when we configure on vSphere level, that can be considered as vSphere virtual volumes only. So that's why I mentioned specially vSphere virtual volumes. It's not belongs to the third party virtual volumes. Now, so we know the second row also data store type. We know we have a four types of data store. Now comes to the within a VMFS, what is the supported protocols? Using VMFS, direct attached means local storage. Direct attached, that disk is directly connected to our motherboard. So local storage, another name is direct attached storage. Okay, so the protocol for the transport is nothing but a protocol. How the data is transferred, the transfer protocol is direct attach protocol dash, and and also it will store on a disk only. The type of the data storing, backing means storing the data backing up in a disk format only. Within the disk we can copy with a VMFS format. That is the first one. And let's understand the second one. Suppose if you are using a fiber channel SAN, the protocol name is fiber channel only. The name itself have a same protocol, fiber channel protocol. And but in the fiber channel, when you want to store your all the virtual machine data within the VMFS format, that storage level, the data store name is considered as a LUN. LUN full form is logical unit number. If you create a one logical unit number, it has a unique LUN ID. Okay, so similar like a our NIC code, every NIC code have a unique MAC address. Similarly, even the LUNs also have a unique IDs. That unique ID dedicated for specific LUN only. So if you want to create the LUN, first we can create the LUN on a FCSAN level. That LUN we can present it to the ESX host as a VMFS data store only. In the backend, it's a LUN. But when it comes to the vSphere ESXi host level, we consider as a FCSAN data store and file system format is VMFS. And within the FC SAN, there is a other SANs also available. FC is a very high configured, costliest box. But if you want to reduce your FC SAN cost, there is a another protocol is available, that is fiber channel over Ethernet. E means Ethernet. Instead of for FC SAN, we need to purchase a fiber channel switches. It is usually it's a very costly switches. Suppose you don't want to invest on the fiber channel switches. The best way to go for a FCOE protocol. FCOE means for FCOE, we no need a fiber channel switches. We can configure FCOE on a normal network switches. So that is the reason we call it as a fiber channel over Ethernet. Ethernet means our LAN network. So if you configure FCOE protocol also, you can directly access our SAN storage LUNs. Okay. When we assign this LUN to the using FCOE protocol, but it comes to the ESX host, it's format as a VMFS. Same like our local storage, we have a disk. Yesterday we added a disk. How much the disk we added? One disk we added as a around 40 GB. But when we connect to the ESX host, it's formatted with a VMFS file system format. It's the same like your home system. If you have any thumb drive, when you connect to Windows system, default it will format with a NTFS. The same thumb drive, if you want to use it on any of the Mac system or Linux based system, we need to format with a supported file system format only, like ext4 you can format. Then only that format will be recognized by specific operating system. Similarly, even whatever the LUN we have, FC LUN or FCOE LUN, when it comes to the ESX level, the storage format is configured as a VMFS format. So VMFS supported disks are, this is the one direct attached one, FCSAN and FCOE. Similarly, other storage. This is also compared to FCSAN. It's a medium cost storage, but the only difference in the iSCSI is Internet SCSI. SCSI means small computer system interface. For Internet SCSI, instead of using a fiber channel switches, even the iSCSI also uses a normal switches. Only the protocol different. Here the protocol is FCOE. Here the protocol is iSCSI. But how we can differentiate these two is, if you want to configure FCOE, remember that in our ESXi host hardware level, we need to have a FCOE physical HBA adapter. What is a HBA adapter means? Yesterday we discussed. Same like our network card. If you want to access the storage system, our hardware must have a one adapter. That adapter name is HBA. HBA full form is host bus adapter. If you want to configure FCOE, we must have a FCOE supported adapter. Suppose I want to configure iSCSI. If you want to configure iSCSI on ESXi level, we must have a iSCSI hardware HBA. If you have iSCSI hardware HBA card, it will allow you to configure a iSCSI LAN. But when you configure iSCSI LAN, the same LAN, while presenting to the VSX host, it will format as a VMFS file system format. Okay, this is about the VMFS file system. How, which protocol we are using, and what is the terminology we are using in a storage level. Okay, and comes to the NFS. NFS we are going to discuss today in more detail, and even in the NFS architecture also, file system you can configure on any of the server, either any NAS device or NAS server. Anything you can use. Once you configure the NAS file system, the same NAS file system, we can access to Ethernet. Ethernet is nothing but a local area connection, LAN connection only. Through LAN connection, we can assign this file system data to our ESXi host, shared storage only. But when we assign the file system data to ESX host, it will format with a NFS format. NFS full form is network file system format. Okay. So this is about the NFS. And let's come to the vSAN. vSAN is nothing but we have to configure a vSAN cluster. Suppose if you have a 3SX host, within this 3SX host, when we purchase the each box, suppose your box is comes with a additional hard drives. Let's say this box have a 4 hard drives, this box have a 4 additional hard drives, this box also have a 4 additional hard drive. All the 4 totally how many disks, totally 12 hard disks. All these 12 hard disks you make it and configure as a one vSAN cluster. We can configure directly on a direct attached disks only. We no need any external storage box, but we are configuring using vSphere vSAN software. So that is the reason we call this as a software defined storage. But which software we are using? VMware vSAN software. Using that vSAN, our local hard disk, or we make all the local hard disk as a one cluster. That cluster is comes from the direct attached disk. This disk, when we present into the ESXi host, it's presented the format as a vSAN, virtual storage area network format. And in our later class, I will show you the lab for vSAN also. And once we familiar with the first three data store, finally we observe the vSphere virtual volumes. And vSphere virtual volumes, as I mentioned, it requires a storage container. This storage container can be either FCSAN, iSCSI SAN, any of the sandbox, FCOE sandbox, any type of storage you can configure with these protocols, FC or Ethernet protocol. But when we presenting to the ESX host, the file system will be format with a vSphere virtual volume format. Okay, so this is about the vSphere storage overview. So today we can deep dive into the NFS. Okay, and the subsequent sessions will deep dive into the VMFS and vSAN. And this is only the basic overview of vSphere supported data stores. And in the last point I mentioned as ESXi host should be configured with a shared access to data store. Always the recommendation is shared access only. In order to get all our vCenter features like vMotion, HA, DRS and all, the minimum recommendation is ESXi host virtual machines must configure only on a shared storage only. It's not recommended to configure on a local storage. Okay, but in our lab, just for our testing purpose, I created one virtual machine just now. But in the real production environment, always recommend is configure virtual machines only on a shared storage only, because when we configure on shared storage, we'll get all the features will be applicable. Okay. Is there any questions on this point? vSphere storage overview. Okay, if no questions, I'm trying to elaborate this all the points. I will show you the definitions for each point. See, in the vSphere storage technologies, within the vSphere storage technologies, what they mention is in the vSphere environment, ESXi host, vCenter support several storage technologies. So these several technologies are DAS, direct attached storage, fiber channel SAN, and FCOE. Let's understand what is mean by DAS. DAS means it's an internal or external storage disk or arrays. Array means it's a storage array. We can also call it as just a bunch of disk. In short form, we call it as JBOD. For our local system, ESXi host, you can connect either internal means local direct disk, or you can use any external storage disk, or you can connect a JBOD. JBOD means bunch of disk you can connect to ESX host. That is also considered as a direct attached storage. So when you connect a direct attached storage to the host through a direct connection instead of network connection. If there is no network connection means it is considered as a direct attached storage. So the same point here, direct attached. There is no network connection, directly connected to the ESX box. Now the second point, fiber channel. Fiber channel means a high-speed transport protocol used for storage area networks. Fiber channel encapsulates SCSI commands which are transmitted between fiber channel nodes. Okay, SCSI command means small computer system interface commands. And in general, a fiber channel node is a server or a storage system or a tape drive. Anything can be configured as a fiber channel storage. And in order to configure the fiber channel, as we discussed, it requires a fiber channel switch interconnects multiple nodes, forming the fabric in a fiber channel network. When we connect with a normally with a normal network switches, we call it as a IP network. But when we connect with a fiber channel switch, we consider as a fabric network. Okay, fiber channel network, or we can say fabric network. Try to understand this terminology, because this terminology will use in the moving forward. And FCOE. FCOE means the fiber channel traffic is encapsulated into a fiber channel over Ethernet. That is short form is FCOE frames, and these FCOE frames are converged with other types of traffic on the Ethernet network. Okay, so other traffic of the Ethernet network. So let's move on to the next slide. Some more additional points. So this is also the iSCSI. iSCSI means a SCSI transport protocol providing the access to storage device and cabling over a standard TCP IP network. Okay, IP network, that is the reason we call it as Internet SCSI. And iSCSI maps SCSI block oriented storage over TCP IP, and also it requires initiators such as iSCSI host bus adapter. To connect our iSCSI storage, as I mentioned, we require a iSCSI HBA code in an ESXi host and send SCSI commands to target. Target means our destination iSCSI box, and located in a iSCSI storage systems. Okay, this is about the iSCSI. Now comes to the NAS, network attached storage. Network attached storage means storage shared over the standard TCP IP network at the file system level. That means our server is connected to the our NAS box. In between, the main connected device is network switch. Okay, network switch means it considered as a standard TCP IP networks, and NAS storage is used to hold NFS data stores only. And NFS protocol doesn't support SCSI commands. So when we are using a NAS storage, the supported protocol is only NFS protocol. It won't support for a SCSI commands. And one important point is FCOE, iSCSI, and NAS can run high-speed networks providing increased storage performance levels and ensuring sufficient bandwidth. Because these three storages, FCOE, iSCSI, and NAS, these three are uses a normal network switch only, but that network switch they recommend to run on a high speed network only because of storage access. There will be a multiple VMs trying to access same time. So that means we should maintain a high network bandwidth. And with the sufficient bandwidth, multiple types of high bandwidth protocol traffic can coexist on the same network. Even though if you are using a same network switches with a high bandwidth like 20 Gbps bandwidth or recommended speed is 10 Gbps Ethernet speed. When you are using 10 Gbps Ethernet speed, the same network is supported for the three protocols. You can use in the same network. That is the reason we mentioned the protocol traffic can coexist on the same network. The same network, you can use the FCOU traffic, you can use the iSCSI traffic, you can use the NAS traffic. There will be no impact. Okay, so this is the vSphere storage technologies. The same thing we covered in the storage overview. So until now, is it clear or any questions? Once we clear here, we'll go some more deep. It seems no questions. So let me go some more deeper level. Okay, so this is the vSphere storage with conceptual diagram. So in this conceptual diagram, the same storage overview diagram, I'm trying to elaborate some more points. Okay, so VMs are accessing different types of storage. It's true. VMs we can access from the, if you have observed the first one, it's like a virtual machine have a VMDK. This VMDK disk file stored on a local disk. Local disk means it's a kind of SCSI device or SAS disk. Any of the SAS disk, flash disk, any local disk, it's a used protocol is SCSI only, and we consider as a SCSI device. When we format with the local hard disk, what is the file system? VMFS file system. This is the first scenario. And come to the second scenario, storage area network SAN. Within a SAN, we have a fiber channel SAN. Fiber channel SAN means it consists of all the fiber channel storage hard disk. All the hard disk or whatever hard disk we are using in the SCSI, the same hard disk, just a bunch of disk we configured in a fiber channel. So that's the reason here I highlighted as a fiber channel array. Array means all the bunch of disks. Using the disk, we can configure as a one LAN. That LAN, when we present it to the ESXi host, it's presented as a VMFS storage only. Using this VMFS storage, we can, if you want to present it to the ESXi host, this entire green color box is represented as a ESXi host. Okay, but within one ESX box, we are trying to discuss the all concepts. Okay, the first concept refers as a local storage, and the second concept referred as a SAN storage. But the SAN storage, what is the main key component? To access your sandbox within our ESXi host level, we required a fiber channel HBA card. If we have this physical card, then only we can connect to the SAN storage switch. From the switch, we can access the fiber channel LAN. Okay, this is the connectivity process. Okay, the same connectivity process I will explain in detail in the next class. But to try to understand, FCSAN means same like our network storage, we require a network card. But if you want to access a fiber channel SAN, we require a card name called fiber channel HBA. HBA full form is host bus adapter. Okay, so using this host bus adapter, you can create a virtual machine and store the virtual machine directly on a SAN storage, FC SAN storage LAN, and it's formatted with a VMFS file system only. Okay, so hope you clear about the second column. Now comes to the third column. Even in the third column, our ESXi host trying to access to the storage only, but this storage is a iSCSI array. iSCSI array means it's a iSCSI storage area network. It consists of multiple hard disk. So within the iSCSI also, we have a two types of Ethernet cards. You can use iSCSI HBA hardware card, or you can use a software iSCSI adapter. This facility also we have software iSCSI adapter. When you don't have a hardware card, you can go for a software iSCSI adapter. But this software iSCSI adapter we can configure on a OS level itself. That is the reason we call it as it's a software iSCSI adapter. But this adapter also communicate using a normal network interface card only. Using normal network interface card, it will connect it to the LAN switch. From the switch, we can access the iSCSI SAN. This is the connectivity process. When comes to the iSCSI HBA, this is iSCSI HBA card. Using this card, we can connect to the LAN switch. From the LAN switch, we can access a iSCSI storage. This is the usual connectivity process. When we connect, virtual machine directly comes here and stored on a iSCSI LAN. And same way, even in the software iSCSI adapter also, when we connect the software iSCSI adapter through normal network card, connect to our switch and switch to iSCSI storage. And once we connect, the connection is established, the virtual machine comes and directly stored on a iSCSI LAN. So the third row refers as a mainly iSCSI LANs only. But iSCSI LAN, remember that you can configure either hardware iSCSI or software iSCSI. But when we compare the software and hardware, normally the usually you will get the better performance in iSCSI hardware card only. When we use iSCSI HBA card, it's a hardware device. When we use hardware device, you will get the better performance. But when we use a software iSCSI, we won't get the equal as hardware performance. We will get here some medium range performance. Okay, and also this VMs also require a TCP/IP connectivity. TCP/IP connectivity means transmission control protocol, internet protocol connectivity. That is nothing but we need a normal LAN switches connectivity. That's why I highlighted as a LAN. Now let's come to the last row. In the last row, if you see here, this is a NAS appliance. NAS appliance means network attached storage appliance. NAS appliance can be, you can use any third-party software, or you can configure on any of the physical server, or you can configure as a direct NAS box also we can purchase from the third-party vendors. Like yesterday we observed HPE also providing one of the NAS box. The name is HPE Storage Ones. Using the HPE Storage Ones box, you can configure a NAS device. But similar to the iSCSI, even to access our NAS device, the only connection process is we require a normal network switch. From the network switch, we can connect to the ESX host. So to connect between the ESX host and the NAS device, we need a switch, and in the ESX level, the main interface is Ethernet NIC. NIC means network interface card. That is our main interface. So based on our storage model, it's easy to remember the interface names also. I repeat, for Fibre Channel SAN, the interface card name is FCHBA. For iSCSI SAN access, you can use iSCSI HBA card. Either you can use hardware card, you can use a software iSCSI also you can use. When comes to the NAS storage, the main interface is normal network interface card. Is it clear? Before I move on to the all the storage comparisons, let me know if you have any questions, because it's a very important concept. Once you understand this conceptual diagram, it's easy to deep dive into the all concepts.
Like for accessing any storage, we need one HBA card, right?
One HBA card only for a SAN storage access. If you're accessing fiber channel storage, we need fiber channel HBA. This is the model for fiber channel HBA. For iSCSI storage, we have two options. Either we can use iSCSI HBA hardware card, or you can configure as a software iSCSI adapter. If you configure as software iSCSI also, we can connect to the iSCSI. Only the storage area network only we need a HBA cards. For local storage, we no need any card, and even the NAS storage we can access using normal network interface card. Clear?
Okay. Yeah, clear.
Okay. So now we will going to compare the all the storages. Okay. What is the main differences in each and every storage? Okay. This is the comparing types of storage. When you're comparing the types of storage, each different protocol has its own set of supported feature. Obviously, when we use any specific protocol, each protocol have some set of supported features. So we'll observe one by one. Just now we discussed fiber channel SAN. So fiber channel SAN, the technology name also we call it as fiber channel technology. Within this technology, the supported protocol is fiber channel protocol, or else we can use a SCSI protocol. Any protocol we can use, because inside the fiber channel SAN also there is a plenty of SCSI hard disk or SAS hard disk. So the supported protocols are FC protocol and SCSI protocol. And the data, how we transfer the data is, data transfer is mainly into the block access of data. We discussed it's a block storage. Our FCSAN is a block storage. So block access of data, or the data is stored directly on a LUN. LUN means logical unit number. And the interface, just now we discussed what is the main interface for FCSAN. The interface name is fiber channel HBA card. We need a fiber channel HBA card to access the FCSAN. And now FCOE. FCOE means fiber channel over Ethernet. But fiber channel over Ethernet, the whatever the technology we are using, even the protocol name also same name. FCOE slash SCSI. Any protocol we can use, and the data stored on LAN, and also the interface. If you want to connect our FCOE, we need a hardware FCOE card. This is nothing but a converged network adapter. It's a separate card dedicatedly for FCOE protocol support. Okay, that network card only we have to use. So that network card we call it as a converged network adapter, or we call it as a hardware FCOE card. This card is needed for FCOE access, FCOE SAN access. And similarly, we'll observe the iSCSI. iSCSI SAN also, the protocol is either you can use normal internet protocol or SCSI protocol, and data stored on a LUN only, logical unit number. And here, as we discussed, iSCSI have a two types of adapters. You can use iSCSI HBA card or iSCSI enabled NIC. Some of the hardware NICs also comes with the iSCSI feature. Either you can use iSCSI enabled NIC, or you can use a separate iSCSI HBA hardware card. If you don't have hardware card, there is a facility to configure a software iSCSI. When you enable software iSCSI feature, our network card also acts as a iSCSI adapter card. Okay, so any method we can use. Now, another type of technology we are using is NAS. NAS means network attached storage. Here protocol is NFS protocol, and the data is stored in a file only. It's not the block. Today we observed one logical diagram. Even in the NAS storage, the only logic is it is a file storage, and the protocol is NFS. So same point I highlighted here in the table. So NAS system, it's only the file storage, and the only the interface we used for the NAS storage is network adapter. The same point we highlighted in the diagram also. For LAN access, NAS storage access, we need a Ethernet card. Okay, Ethernet card. And virtual SAN. Virtual SAN means we can configure virtual SAN directly on a direct attached storage. So the protocol name also vSAN, and it is a block access of data. Block access of data means it's a existing local direct attached disks only. And the interface, if I want to connect from one ESX host to another ESXi host, one ESX to another ESXi host, even in the vSAN, the main interface is normal network interface card only. And comes to the vVol. vVol means virtual volume, and virtual volume also software defined storage. This can be configured either on your fiber channel SAN, or you can configure on your iSCSI SAN. And also not only limited to fiber channel and iSCSI, you can configure any of the storage container like NAS storage also. So that is the reason it supported data transfers are, you can format in a VMFS or you can format in a NFS. Two options are available for virtual volumes. And the interface also, you can use for NAS storage means you can use the interface is NIC. For SAN storage, you can use the interface as HBA card, host bus adapter card. Okay, so this is the protocol wise what is the features we have, and let me elaborate with the vSphere features also. We can verify the vSphere supported features also in the next slide. Let's move on to the next slide. So here, if you observe here, vSphere features supported by storage. So we just now observe this is the storages are available: local storage, fiber channel SAN, iSCSI SAN, NAS storage, vSAN, and also we have virtual volumes. This all the storages is supported for boot virtual machine. We can create a virtual machine on any type of storage. We can boot. All these features are supported. So that's why I mention as yes. But when comes to ESXi boot from SAN, if I want to boot, the name itself says ESXi boot from SAN. That means this feature is available only on the SAN storages only. SAN storage means fiber channel SAN, iSCSI SAN. These two features are supported for boot from SAN. Local storage it won't support, and also the NFS no, all the others are no. And let's observe the data store file system versions. When we use the local data store, the data store file system version VMFS is latest version is 6, and fiber channel also supported for VMFS 6, iSCSI also 6. And comes to the NFS, within the NFS we have a two types of file system versions, NFS version 3 and the latest version is 4.1. But in the 4.1 still some of the features are not compatible like NFS 3. Maybe in the future editions, VMware may provide the all enhanced features in NFS 4.1. So based on our requirement, any version we can choose. But all vSphere features supported only in the NFS 3. NFS 4.1, only few features are supported. Okay, and vSAN also the data store for vSAN storage, and virtual volumes we can format in any type. Either VMFS format it support or NFS format it support, because it's a software defined storage. And now RDM. RDM is also a separate concept, but try to understand the definition for RDM. RDM means raw device mapping. If I want to provide my virtual machine direct access to the storage sandbox, that is nothing but a RDM. So RDM, it's provide direct access only on the sandbox only. So the sandbox features only available, yes, the remaining are no. The features are not applicable. Okay, and VM cluster means, suppose if you want to configure a cluster in vCenter level, cluster is nothing but a grouping of multiple ESXi host. The similar concept, even if you want to group the multiple virtual machine, VM level cluster like a SQL cluster, SQL failover cluster, if you want to configure a VM level cluster, we can configure only on a SAN storage and software defined storage. That feature is not available only in a NAS storage, network file storage only, it's not available. The remaining all the storage models, we have a VM cluster facility. I put a star mark those points I mentioned below. Okay, and vmotion we know it's a migrating virtual machine from one host to another host. That feature is available for all types of storage. And even HA, for HA and DRS features, the recommendation is shared storage. Our local storage is not a shared one. Except local storage, the remaining all the storages are supported for HA and DRS. Okay, just understand the feature name itself. Later classes I explain in detail each feature, vMotion feature, HA feature, and DRS feature. But in order to provide the support for all the feature, also whenever we are trying to purchase any of the sandbox or NAS box, before purchasing, we need to validate uh, our storage is supporting for all features or not. But most of the time, all the vSphere features supported for all the storages except the local storage. Local storage only, it won't support for RDM and also HADRS. Okay, and come to the last option, storage APIs. API means application program interfaces for data protection. Data protection is nothing but a virtual machine's backup. In order to take the virtual machine backup, we can take the backup from any storage. You can take backup from local storage, fiber channel SAN, iSCSI SAN, any type of storage we can able to take the backup. Okay, so this is about the vSphere features supported by our existing storages. Suppose I'm planning to configure a RDMs in my environment, raw device mapping. So which storage is recommended? If I want to configure RDM, which storage we prefer to choose?
Either fiber channel or SCSI.
Yeah, we can choose either fiber channel SAN or iSCSI SAN. So based on our requirement only, we'll go to the specific storages. Suppose I do not have a much budget. I don't want the RDM configuration, but I need a vMotion HA DRS. These three features are needed, but I need a low cost storage box. So which storage we prefer for low cost? But
NAS.
we can go for a NAS storage, or we can go for a vSAN or virtual volumes. These three are the compared to iSCSI SAN and FC SAN, the storage cost is minimal cost only. I mean medium range of cost. It's not a high cost like FC SAN and iSCSI SAN. Okay. So when the customer given their requirement, understand the customer requirement first. Based on the customer requirement only, as a VMware vSphere systems engineer, we can recommend the specific storage models in the real-time scenarios. Okay. But based on my experience, most of the companies they minimally use two types of data stores. One is Fibre Channel SAN or iSCSI SAN, and the second scenario they will use NAS storage or vSAN storage. But most of the production critical servers they prefer to choose a Fibre Channel SAN or iSCSI SAN, subjected to be customer budget. And test VMs and development VMs they prefer to go with a either software defined storage, or they can go for a NAS storage. Okay. That is the way we can categorize our environment virtual machines. Now let's try to understand some important points. Local storage support a cluster of virtual machines on a single host. See, in the VM cluster we mentioned that it's supported, but the only condition they given in the VMware article is local storage supports a cluster of virtual machine on a single host. If you want to configure virtual machine cluster on a local storage level, the two virtual machine must run on a single ESXi host. If you want to move it to another host, again the cluster may not work. So that is the condition they given. That's why I put a star mark. Star means it's nothing but a condition supply. And vMotion also there is some condition supply. See, a shared virtual disk is required. Normally for vMotion, a shared virtual disk is required. But in the DAS means local storage, supports vSphere vMotion when combined with vSphere storage vMotion. Suppose I want to move a virtual machine. Let's quickly connect to our lab system. If I want to move this virtual machine from one ESX to another ESX host, right click the virtual machine and you can choose migrate. When I choose the migrate, there is a multiple options. Change the computer source. Computer source means it's only changing the ESX box, but it won't change the data store location. Suppose if I select a second option, change it to storage only. Storage only means it won't change the ESX host location. It will change only the data store location. That means the first option refers as a vMotion, second option refers as a storage vMotion. Even in the VMware also given a clear notes here. Compute resource means migrate the virtual machine to another host or cluster. This is called vMotion. Storage only means it's a storage vMotion. Migrate the virtual machine's storage to a compatible data store or other data store cluster. This is the storage vMotion. But when we are trying to use a local storage virtual machine, VMware recommend to choose this option. Change both compute and storage. The same point they mentioned here. Local storage dash supports vSphere vMotion when combined with vSphere storage vMotion. vSphere storage vMotion means while migrating the virtual machine, local storage virtual machine, we have to choose the third option. Third option is it comes with both vMotion as well as storage vMotion, compute resource and also the storage. Okay. And the last option is cross vCenter export. Cross vCenter export means suppose if you have a multiple organizations like primary site, secondary site, if you want to migrate virtual machine from my primary site to secondary site, that scenario will use the fourth option. So migrate the virtual machine to another vCenter not linked to the current SSO domain. Even no need SSO domain link, even though we can do a cross vCenter export. Okay. Suppose this is a virtual machine, it's a kind of software generated machine, we can able to migrate quickly and easily. The same scenario, if I want to migrate the physical server from one data center to another data center, usually how long will it take? Let's say my data center, primary data center is in Hyderabad and my secondary data center is in Delhi. If I want to migrate the virtual machine from Hyderabad to Delhi, we require a wide area network. Network bandwidth also matters. We require a minimally 1 GB and the recommended is 10 GB. Even if you have more than 10 GB, it's quickly allow you to migrate the virtual machine from Hyderabad network data vCenter to, you can quickly migrate it to the Delhi data center vCenter. Suppose the same scenario, instead of virtual machine, if I want to migrate a physical server, usually how long will it take?
Several days.
It will take several days. If I want to migrate a physical server, the procedure is we need to contact the respective server owner. Suppose that server is one of the application, one of the SQL application is running. We need to contact the specific application owner. We are planning to move the server to our remote site, Delhi site. So when is the best time to power down the server? We need to get the downtime approval from the application owner. Normally getting the application owner approval, roughly it may take 1 week time. Once we get the application owner approval, we need to power off the physical server. And again, we need to contact the any of the third party vendors like packets and movers. The movers will help us to do the all the server packing, and they will transport on either in a on-road basis or in a air base also. We can move server from Hyderabad location to Delhi data center. Even once the server is reached our remote location, again we have to unpack the all the packings and place the server into our respective rack. Once we mount the server in the rack, you can try to connect all the cablings. Once all the cables are connected, you can bring up. So it may take several few days to reach our server from one location to another location. But in the virtual machine, we no need to take any downtime. On fly, you can just right click and migrate. That facility is available. But only condition from the VMware is in order to do the virtual machine vMotion, we must have a shared storages. Shared storage means either you can use fiber channel SAN, iSCSI SAN, or NAS storage, vSAN, any of the software defined storages also you can use to migrate the live virtual machines. But only in the local storage scenario, they are given condition is it's not recommended to migrate only the host resources. You can also migrate along with combined with storage vMotion. Okay, that is the point highlighted here. Clear? Okay. So now we quickly jump onto the our NAS storage architecture. So until now we discussed the complete vSphere storage technologies and the basic overview. Now we'll trying to focus on a NAS storage architecture today. So this is the NAS storage architecture. So NAS storage architecture is same, just whatever we discussed. We have a 2 ESXi host and ESX host running with multiple virtual machines, and all this virtual machine data is stored on a NAS storage. That NAS storage means normally it a file share only. Normal whatever we files and folder shared, that same folder is presented to the virtual machine as a NAS box. The same point mentioned here. NFS network file system is a file sharing protocol that ESXi host used to communicate with a network attached storage device. So this is the network attached storage device. And NFS supports two versions, NFS version 3 and version 4.1 over TCP IP. Over TCP IP means it's over the our network switch. So this is the supported NFS versions. And to clarity, both NFS and NAS refers to the same type of storage protocol, and the terms will be used interchangeably. Whenever I use the NAS or NFS, don't confuse. Both are refers as a same storage protocol. Sometime we call it as NAS, sometime we call it as NFS. Both are same. Okay, so the terminology is same, either NAS or NFS, but the file system format is always in the NFS. The device we call it as a NFS server or NAS device server. Anything we can call. Okay, now we can observe the NFS storage architecture in a detailed diagram again. This is a basic diagram. Now I'm trying to show you the some elaborated diagram. This is the complete NFS storage architecture with required components. Okay, so let's try to discuss on the NFS storage architecture components now. We'll start from the ESXi host first. In the below, if you observe that we have a ESXi host. Host means ESXi server. And when we install ESX server, by default, it comes with a one virtual switch. So it have a one virtual switch. And to connect our ESXi host to IP network, we need to connect a through network card only. I just mentioned the network card icon also. Using the network interface card, we are connecting to switch. This switch, we call it as a IP network, Internet Protocol Network. From the switch, we are connecting to the NFS server. Either we can say NFS server or NAS server. anything we can call. So for NFS server, to connect to NFS server also, the main interface is network interface card only. But in our NFS server, we have a facility to create, you can create multiple folders. This folder you can share. Once you share this folder to ESXi host, it will become as a NFS data store or NFS shared folder. Okay, so that is about the NFS server data store information. And let's try to read the remaining points. The first point I mentioned here in the ESXi host level is ESXi host with NIC mapped to the virtual switch, correct? Our NIC is mapped to virtual switch only, and VM kernel port defined on virtual switch. Even to manage our ESX host, we need a VM kernel port. Similarly, for our NSX host access also, if you want to configure a additional VM kernel port to group, we can also configure on a vSwitch level. That facility is available on a vSwitch. And we already know how to create a virtual switch and how to create a VM kernel port group and VM network port group. But in this NFS storage scenario, what is the required port group is VM kernel port group. So once we configure VM kernel port group, using VM kernel port group, we can connect to the network card. From network card, we can connect to the physical network switch. From switch to, we can access a NFS server. Okay, so NFS server also I mentioned points, directory to share with the ESXi host over the network. So we are accessing ESXi host over the network using this NFS shared folder. In order to access from ESX to this shared folder, our main media is two network cards and also the switch, and NAS device or a server with storage. So you can configure the NFS in any of the physical box, or even any server also you can make it as a NFS server. But in our today's lab session, how I'm going to configure the NFS server is, we do not have a NAS box in our home lab environment. Yesterday I shown you, if you want to configure a NAS box, we can purchase some physical NAS storage boxes. If you do not have a storage boxes, we have a facility to configure NFS on any of the server. So today's session, I'm going to show you in our Windows 2022 server, we already have a Active Directory and DNS. The same Windows server, I will configure a NFS server role, network file system role. If we configure NFS role, that server also become as a NFS server. Okay, I will show you how to configure a NFS server. Okay, let's observe the remaining points also. An NFS file system is located on a NAS device that is called NFS server. Okay, so both names are same. Either you can use NAS device or NFS server. Any name we can use. The NFS server contain one or more directories. See, it's not like only one directory. You can create multiple directories also. So one or more directories that are shared with the ESXi host over a TCP IP network. TCP IP network means through the switch we can provide the access. And an ESXi host access the NFS server through which port is required? VM kernel port. So this is also one of the interview question, or you may expect in a VCP certification exam. They may ask what is the required port group to connect from ESXi host to NFS server. So to connect from ESXi host to NFS server, the required port group is VM kernel port group. Okay, VM kernel port that is defined on a virtual switch. Okay, so this is about the NFS storage architecture and components. What is the main key components we are using? Is it clear? Once you are clear, I will explain some more additional points. If you have any questions, let me know here. Okay, let's move on to the next slide with the additional points. So NFS storage architecture, it's a continuation. And now we are going to observe the addressing and access control with NFS. How we can addressing the NFS and also the access control. Addressing is nothing but a IP address or host name. If you want to find the NFS server detail, you can use a NFS server IP or NFS server host name. That is called addressing. And access control means, access control is nothing but a, if you want to access from ESXi host to NFS server, we require a login credentials. For a NFS server is a Windows server means we need a Windows administrator credential or any equivalent administrator credential. Suppose if you configured NFS on any Linux server means we require a root credentials or equivalent root permission credential. If you have that credential, we can quickly access the NAS server through our IP network switch. So the same NFS architecture in this diagram, I'm trying to explain some additional points. Let's start one by one. The first point is ESXi host access the NFS server through the NFS server IP address or hostname. It's correct. So in our diagram, I mentioned that our Active Directory DNS server IP, because today's lab, the same server .70 IP only, I'm going to make that server as a additional role, that is NFS role. So that means this server also become as a NFS server, and the directory to share with the ESX. You can create the directories also today. We can create multiple directories to provide the access to ESXi host. That is about the first point. Let's come to the second point. The VM kernel port is configured with an IP address. Even if you want to configure VM kernel port on ESXi host, we should configure with the IP address. I'm trying to use our same IP address 71. You can use the same management VM kernel port group port IP, or you can create a new dedicated VM kernel IP also. Why I mention as other is sometime in real time scenarios, suppose your NFS server is not in the same series of network. If it is in the different series like 192.168.11 series, if you have NFS server is in a different series, during that time we need a additional VM kernel port group also with the same network series. So that point I mentioned here, VM kernel port is configured with an IP address. This IP address makes sure that within the NFS server series. Okay, and NFS version. NFS version, we have a 4.1 and version 3. Both are supported for our vSphere 7.x. Why I mention X is we have a latest updates also. vSphere 7.0, update 1, update 2, update 3. Three updates are available. All the updates we simply mention as any updates, we mention as a shortcut word X. Any X means any update. And last point, different features are supported with a different version of protocol. Obviously, when we use a different version, it supported a difference of features. Here, I'm trying to explain a few features for these two versions, version 4.1 and 3. NFS 4.1 supports multipathing unlike NFS 3. That means NFS 3 will not have a feature for multipathing. Multipathing feature is available only in the NFS version 4.1. Here, multipathing means, let's try to understand the multipathing from our diagram. Suppose if you refer the architecture diagram, here there is a connectivities. Suppose in our previous diagram, I mentioned as our architecture with each NFS server, one NFS server running with one NIC card, host running with one NIC card. But in the real-time production scenario, one NIC card is the not recommended scenario. We should maintain minimally two NIC cards for redundancy purpose, because we are not sure when this network card network card will be down, or it's having some functionality issues. During that scenario, if you have a second NIC card, it won't impact your ESX host access. When the one NIC card is down, we can connect from a second NIC card. So that recommendation I highlighted in the this diagram. If you refer here, this ESX host running with the two NIC cards, even our NFS server also running with two NIC cards. But try to understand the connectivity, how we connected. This ESXi host network card, if you observe the green line, it's connected to the switch. Again, from the switch, another cable is connected to the NFS server. So this green line refers the direct one communication. And if you refer the yellow color line, this is also connected from second NIC to connected to switch, but this switch is not the first switch. We use the second switch and connected here. And from this here, another cable connected to NIC card. So this is nothing but a one ESX host have a not a single path connection, it have a dual path connection. So when we have a dual path connection from host or NFS, this is nothing but a multi-pathing. So we have a multiple paths. Either you can go from network card one path, or you can go for a network card two path. But the benefit of multi-pathing is, what is the benefit? Suppose my network card is down on ESX host level. Still we can access from second NIC card. Suppose my NFS server, one NIC card is down. Still we can access from another NIC card. So even my physical switch, the port is completely shut down. Not the switch is shut down, the specific port is shut down. Even in the physical switch level, there is a command to port up, port down command. Suppose accidentally our network team, or while performing their maintenance, our specific network port is down. even when the your switch level network port down also, we are unable to connect from the second path. During that time, we can connect from the first path. So which is the recommended connection in the real-time scenario? Shall we use the one path to connect NFS server, or will use the dual path? Dual path, or we can say multi-path.
We'll use multipath.
We'll use multipathing. But if we want to use a multipathing feature available only in a NFS 4.1 version only. It's not available in a version 3. Okay, that is the point I mentioned here. And comes to the NFS 3, another point is NFS 3 support all vSphere features because it's a previous version. It support all vSphere features. vSphere features means the main key features: vMotion, HEA, DRS, RDM, and also there's some additional backup feature like data protection and so on. All these features supported in a VMFS 3, NFS 3, sorry. But when it comes to NFS 4.1, there is some limitations. NFS 4.1 doesn't support storage DRS. Storage DRS also one of the feature. Storage distribute resource scheduler. This feature is not supporting in a 4.1, and even vSphere storage IO control feature also not available, and vCenter site recovery manager. If I want to use SRM product, this SRM also NFS 4.1 is not supported because NFS 4.1 is very latest product. There are some limitations at present. Maybe in the future releases like 4.2 or NFS, they may upgrade it to NFS 5. Maybe in the future releases, VMware may release with the full compatible version. But at present situation, NFS 4.1 is there is some limitations. It won't support for all vSphere features. Whatever the features it's not supporting, I highlighted here. Storage DRS, vSphere storage IO control, vCenter server site recovery manager, and virtual volumes. Even in future, if I want to configure virtual volume on NFS storage, if you are using a 4.1, it's not supported. Okay, so but today's lab, for our future lab purpose, will go with a NFS 3 due to this support limitations. Okay, now I'm going to show you the NFS data store configuration. So how the configuration in the real-time scenario. This is the usual configuration steps. If you want to configure NFS data store, as I mentioned, we need to create a VM kernel port for better performance and security. Separate our NFS network from iSCSI network. Suppose if I have a iSCSI network, better don't use the same VM kernel port group. Always maintain a two VM kernel port group. One VM kernel port group dedicatedly for NFS and another VM kernel port group dedicatedly for iSCSI network, mainly for better performance. Okay, and provide the following information. While we creating NFS storage data store configuration, these details are important. NFS version 3 or version 4.1, we need to choose one version. But in our lab, for our future lab purposes and all vSphere feature purpose, I'm going to choose a via NFS version 3. Okay, and before creation of NFS version 3, we need to choose which name we are planning to assign, data store name. Normally in the real-time scenario, there will be some data store naming convention. Based on your company naming convention, we need to choose the data store name. Okay, but in our lab, we can put any of the name. And we also need a NFS server name and also the IP address. If you have NFS server IP address, it's good to start the configuration. And we also need a folder on the NFS server. Which folder we are going to give? Either you can give as a name as ISO, or you can give as /templates or NFS share. I given some example names. Not only this name, you can keep any name. That folder also we needed to share to provide the access to the ESX host, and select the host that will mount the data store, which host you want to connect. Suppose in our lab, we have a 3SX host, and which host you want to first configure a NFS storage. So that specific host also we need to choose, and whether to mount the NFS file system read only or read write. Normally in the real time scenario, always we configure as a read write storage, not for a read only scenario. And we also require a authentication parameters. Authentication means from our ESXi host, we are connecting NFS. So we need a NFS server credentials to access the our shared folder as a NFS storage. Okay, this is the actual configuration step. But in our lab, we need to include some additional steps. That additional steps I'm explaining here. Okay, so what is our NAS server build procedure and create NFS data store? This is the pre-configuration steps, configuration procedure, and post-installation steps. So before we start the NFS lab, it may take roughly 30 minutes time. So shall we take the short break and we'll start the lab, or can I continue? What is your preference? Can I continue or we'll take the short break?
We'll take the break.
Okay. So now the time is 9:53. Okay, we'll start by 10:10. Okay, 15
Okay.
minutes break. Okay. 10:10 we'll start the home lab.
Okay, sir.
Okay. Thank you.